Hello world, I edited this video in Adobe Premiere, and when I was done, I exported it to a video file. Now you probably know what a video file is. I mean, we're all familiar with the concept of what files are, but did you know that in Linux, everything is a file? I'm Ryan, and welcome back to Intro to Hacking with Hack the Box Academy. In this video, we're finally going to get our hands on Linux. We're going to be talking about the Linux file structure, system information, how to navigate and use the terminal, and more. I don't even want to waste any time building up to it, so let's just jump right in. So the first thing to do is to head back to the Linux Fundamentals module that we started in the last video. So go to your dashboard, click on Start or Continue with Linux Fundamentals, and head back over to the Linux Structure section. In the last video, we mostly talked about this, the history of Linux and mostly GNU. But in this video, I want to start off with the Linux file system, and more specifically, the Filesystem Hierarchy Standard, FHS, which is a standard for how Unix-like systems should have their file system organized and structured. Now, to be clear, a file system is just the way that an operating system organizes and structures its files and directory. It's not some voodoo black magic, that's really all it is. Now, to talk about this, we should first start up our Pwnbox workstation, our in-browser Linux Parrot Security VM. Now, I already have mine spun up, but you can start yours right over here where it says My Workstation, and I'm just going to switch to the tab where I have that full screened. Now, this is a full Linux VM, as I mentioned before. We can do things like start up Bash, or open up Sublime, or go to Firefox. But for right now, what I want to do is open up Kaja, which is an app that's basically a file explorer. It lets us visually view the file system. So we're going to go to Places, and then go to Home folder. And this opens up our home folder. This is where you live. For me, this is the HTB-AC464110 folder, because that's my user ID on Hack the Box Academy for this account. And here I can find my desktop, my documents, my downloads, and you will have something similar. And this probably isn't that unfamiliar of a concept. If you're using Windows, you also have a home folder, and that's going to have your desktop, your documents, your pictures, your videos, things like that in it. So you've probably seen something like this before. It's not some weird alien idea to have a home folder that is dedicated for whichever user you're currently logged in as. But what I want you to do for now, we'll come back to this later, is click on this little arrow here and go to this slash folder. This is the root directory of the file system. We can also see it over here if we click on File System. I can see it this way because I have the view set to tree, so go ahead and do that if you want to. But we can see all of the folders that are in the root of the file system. So when I say root of the file system, I mean this is the highest level of the file system. It's comparable to the C drive on Windows, the C folder, the highest level directory that you can reach. Everything that is on Linux is inside of this slash folder. We call that the root directory. Now, that's not to be confused with this folder, which is also called root. That's actually the root user's home folder. So for just clarification purposes, if I'm saying, the root directory, I'm referring to this slash folder. And if I ever want to refer to this, I'll say the root home folder or the slash root folder. Now, you'll have noticed there are a lot of folders in here. I mean, we have bin, boot, dev, etc, home, lib, lib32, lib64, libx32, media mount, so on and so forth. I'm not going to repeat all of these right away. What are all of these for? Well, these are all for different types of files that are stored on the Linux system. The bin folder is for binaries. These are executables. These are programs that you can run, commands that you would run, like ls to list files, cd to change directory, cp to copy a file. Those are in the bin folder. Or to be slightly more accurate, they're really in the user/bin folder, at least on Parrot. On Parrot, the bin folder is actually sort of like a shortcut for the user/bin folder. It points to it. This is what's called a symlink. I'm not going to delve into this too much right now. It's really not super important for you to know this. I just want to mention it. If we were to open up the terminal and we were to change directory, so we can do cd/, and then we'll do ls-l to list directories. So cd to change directory to the root directory, ls to list the directories, -l so we can see a little bit more information. And we can see if we scroll up here that bin is pointing to user/bin. This is called a symlink. Don't worry about too much why this is. This is a carryover from days past where Binaries were separated and segmented into a bit more folders for organizational purposes, but nowadays we kind of just keep them in more centralized locations, particularly in the user folder. This is the same for the lib folders as well. These point to the various lib folders in the user directory. Don't worry about it too much. It's not going to be on the test. There's not going to be a test, but if there were, this wouldn't be on it. If this confuses you, don't worry about it. It's not important to know right now, but let's just keep in mind in the back of our head that when we're going into the bin folder, we're actually going into the user/bin folder. So if I double click on this bin folder, we see a bunch of files. Now these are all executables. These are all files that can be run. They are commands. And in fact, if I open up the terminal again and I type ls, I can see the files in my home folder because the bash is opening up to my home folder. And this ls lists the contents of a directory. But what is ls actually doing? Like, what happens when I type ls? Well, bash, which is the shell, it's the thing that's giving me this little prompt here that's asking me if I want to run a command. It's actually going into the bin folder, the /user/bin folder, and executing the ls file that exists there. So if we cd into /bin, if we change our directory to be bin, and then we type ls, we can scroll up here and we will find the ls command in this folder. We will find the ls executable in this folder. And right here it is. There it is. This is /bin/ls, or more accurately, /user/bin/ls. That's where this file is located. So when I'm typing ls into the terminal, that's what's being run. I could also specify /user/bin/ls if I wanted to run the ls command directly from its executable by specifying exactly where it is on the file system. I can do that, and when I hit enter, it runs ls. Because ls is a file. That command is a file that exists somewhere on the system. Everything is a file. I mentioned this earlier. We'll talk about that more in a second. But keep that in mind. Everything is a file. And all of the commands are binary files. They exist in binary folders, folders that hold binaries. So if we go back out to our root directory, the next directory is boot. And you guess what boot has in it? It has things that are required to boot the operating system. In here is where you'll actually find your compiled and compressed kernel. So if we go into this directory, we can see this file here, which is vmlinux-5.14.0-0.bpo.2-amd64. That's a mouthful. This is the kernel. Remember how we talked about the kernel before? This is the compressed and compiled kernel in its final form. When you take the source code, you actually compile it, you compress it down into a small file. This is it right there. This is the kernel. It's 7.2 megabytes big. It's honestly kind of small. The kernel is a file, and that file gets loaded upon boot. Now in this directory, you'll also notice a initrd file. To explain what that is, we have to talk about what's happening when your operating system boots. The first thing that happens is the bootloader, which is over here, grub, tells the system where to find the kernel. It tells it where to find the kernel file, and it loads that into memory. The second thing that happens is that the kernel needs to mount the root file system. However, in order to do that, it might need access to certain functionality that's not baked into the kernel. It might need to load up some modules in order to allow it to mount the root file system. So where can it find those modules? Well, it can find them on the file system, but it can't mount the file system to get those modules, because in order to do that, it needs the modules, and in order to get the modules, it needs to mount the file system, but it can't mount the file system until it gets the modules. We have a problem. So what you have is you have the initrd file, which contains all of the modules and drivers that the kernel will need in order to continue the boot up process. So grub tells the system where to find the kernel, it loads up the kernel, then it loads up the initrd file, and then the kernel can do the rest of its job of booting the system. So on most systems, your kernel will be accompanied by this initrd file, and these are used to boot the operating system. So moving on, back in our root directory, we see the next directory is dev. And this is where the whole everything is a file really starts to become prominent. Everything on Linux is a file, or at the very least can be represented as a file. And that goes for devices. Let's imagine you plug in a flash drive to your Linux computer. That flash drive is a device, and it will have a file associated with it that represents that device on your system. And that device file will be stored in the dev directory. So let's take a peek in there and see what we can see. So inside of our dev directory, we have a lot of files here. Some of these represent actual devices, or at least the virtual devices that are attached to our virtual machine. Others are pseudo devices. We're not going to worry about this too much right now. Let's see if we can find the storage device that Pwnbox is using. So first of all, let's just figure out what is the storage for Pwnbox. So let's go to our terminal and we can do lsblk. And this tells us that our main disk, which is 160 gigabytes, it looks like, is called VDA. So let's use the terminal for this actually, and I'll make the terminal a little bit bigger for you. Let's cd into /dev, and let's do ls, and see if we can find VDA. So where is VDA? It is right here. There is our storage device that is being used by Pwnbox. It represents 160 gigabytes of storage. This is where our file system is mounted on this storage device, and it's represented by a file on the system. Our device is a file, or at least is being represented by a file. Now, some of you might be wondering if I will take this opportunity to talk about this bad boy right here, this FD file. This FD stands for file descriptor, and file descriptors are a very, very important part of Linux, and I am going to make a very intentional and conscious choice to choose to not talk about them at all in this video at the very least. I thought about it, but I decided this is our first real technical dive into Linux, so maybe we hold off on the file descriptors until a later date. Once we start talking a little bit more about bash, we'll come back to file descriptors, I promise. Moving on, once again, back in the root directory, we have the etc folder. This is for configuration, so this is where your config files are stored. These are usually text files, so any settings that your applications have that can be changed, any configurations they have, are probably going to be stored in the etc folder somewhere. This is pretty self-explanatory, so let's just keep on going. The home directory, this is where home folders live. This is where the user's home folders live. So most of the time, each user on a system will have their own home folder, and they'll have their ability to read and write files in that folder. It's their space for them to do as they please inside their home folder. On Parrot, you'll have one folder inside your home directory, and that will be your user's home folder, which will be named HTB-AC, and then whatever your Academy user ID is. So we've seen this earlier. We talked about it right at the beginning. This is our home folder. Next, we have the lib folder, which is one of these folders that actually points to user. Inside the lib folder, and in fact, inside all of these lib folders, are libraries. This is different shared libraries of compiled code and commands that different applications can use. So for example, libc, the standard C library, the standard library of C commands, will live inside the lib folders, and then any programs can go into these lib folders, find libc, and access it. This is shared commands and code for the applications on your system. Media is where removable devices will get mounted. So as we said earlier, we have device files, which is the actual raw device itself. But then if you want to mount the file system that exists on, say, a flash drive, that would get mounted into the media folder. The mount folder is for mounting temporary file systems. There are times where you might be mounting a full temporary file system and it's not just a typical removable device like, say, a flash drive, but we don't need to really delve into the weeds with that one. Opt stands for optional. That gets its name from back in the olden days when you'd have optional packages, optional software that could be bundled in and added to your system. But nowadays, we mostly use this for user-installed software. Software that's not required for the system to run, but software that you chose to add. So if you were going to install your own packages or install your own programs, they might go into the opt folder. Now we have proc. Proc is a very interesting directory. Now, I said before that the dev folder is really where you can start to see that idea that everything is a file come to life. But maybe even more so with the proc folder, because the proc folder is where the files for processes are stored. A lot of time these are different than maybe some normal files, but they are files nonetheless. The processes are represented by files which are in the proc folder, and I'll show you an example of this right now. So one example of something that's stored in the proc folder is the information about a process that's running. So let's test that out and see what I mean. Let's open up bash, and we'll start up Firefox. We'll make it headless, that way Firefox doesn't actually pop up and open and cover our screen. And we'll also add a fake argument here. We'll pass in some fake information that does nothing to it. So I'll pass in a parameter that is just Ryan is the best. That won't actually do anything, but we're just gonna give it into Firefox anyway. So I'll go ahead and run that, and we can ignore, it's gonna spit out some output here. We'll ignore any output that spits out. But we'll open up a new tab in our terminal, and we'll type psaux, which will get information about the processes that are currently running. And we can see here that this is the binary for Firefox that got run, and that has a process ID of 2318. So let's keep that in mind. The process ID is 2318. So now we'll use the cat command, which just prints out the contents of a file so we can see it. And we'll do cat /proc 2318 /cmdline /command line. And we can see the parameters that were passed into that process. We can see that it was given the headless parameter and the Ryan is the best parameter. Now, if we cd, we change directory into that folder, cd /proc /2318, and we list the contents, we have a bunch of different things here, and this is all of the information about that process. This basically encompasses that process that's being run. We might notice that there's a status file. Let's see what happens when we cat the status file. We get a bunch of information about the process's status. We see the mem file. This is effectively the virtual memory address space of the process. That's a big thing I just said. This effectively represents that process's memory. Our Firefox process has been broken down and represented as a series of files. Back in our root directory once again, we have the root home folder, the /root directory. This is the root user's home folder. It's just like the regular home folder we talked about before, but it's for the root user. The root user is kind of a big deal. They're the super admin of the system, so they get their own special home folder in the root directory of the file system. Next, we have run. This one's a fun one because this is where the demons live. This is where demons, spelt with an A, live. Daemons are services, processes that run in the background that are long-living. They run for a long time. They just kind of sit there in the background, and they provide functionality to other services, or they are themselves a service that just needs to sit there in the background, take requests, always be running. And ones that need to run very, very early in the boot process go in the run folder. There's another directory that daemons use in the var directory, the var/run directory, but that is not available until later in the boot process. So if a daemon needs to run really, really early on in the boot process before that directory becomes available, they can use the run directory. This is where the demons live, but not that kind of demon. The sandbox directory is used for sandboxing. Again, that's a talk for another time. We won't worry about that too much right now. Sbin is for system binaries, system commands and executables that are for root user only. These are commands that directly administer the system, like the shutdown command, the reboot command, certain commands that deal with manipulating the file system directly. That stuff is in the sbin directory, which again is symlinked to the user/sbin directory. So this is actually user/sbin on Parrot at least. The SRV folder is meant to have data that's served by the systems. So if your system serves up data to other processes or systems, that is supposed to go in the SRV directory. However, in practice, this isn't always abided by. A lot of the time, the var folder gets used for that. For example, if you're running a web server with a website, those usually go in the var/www folder, the var/www folder. There seems to be some back and forth on whether or not the best practice should be shifted to use the SRV folder. So according to the Filesystem Hierarchy Standard, for files and data that are served, they go in the SRV folder. Sys is for files that interface with the kernel. It's kind of like /dev or /proc, but specifically for interfacing with the kernel. This is again one of those things that you really don't have to worry about too much. Temp is for temporary files, so if you have a process or program that needs to temporarily create some files and then it's just going to get rid of them right after, you can put them in temp. These files get cleared on reboot by default, so if you wanted to download some files or work with some files and you didn't really care about them, you just wanted to temporarily have them, they go in the temp folder. User, we've talked about a bit. These are files, binaries, data, libraries that can be accessed by users on the system. So inside of the user folder, there's a bin folder, there's library folders, there's a share folder, which is static data files that can be shared. This is all the different stuff that the users might want to share and have access to on the system. Var is for files that are variable and change, so data that changes. Think log files that are constantly updated. This is where websites are usually put because website files are changing and updated as well. Things that are not static and change over time are usually stored in the var folder. Now that's pretty much it for the root directory, and if you found yourself thinking that was a lot, don't worry about it. You don't need to memorize all of the information I just presented right away. What's important is that I initially exposed you to it. As you work with Linux more and more and you gain more experience, you will be exposed to those ideas and concepts naturally. Your understanding will grow as you use Linux more and more, and that will happen on its own. You don't need to freak out about memorizing all of it right away up front. It's not important that you do that. You can 100% use Linux without knowing exactly what each thing in the proc folder is used for. So to finish off this video, I want to talk about some of these commands that are shown in the system information section of the module. Now, make sure you go and you read the introduction to shell, the prompt description, the getting help sections. Go read those, mark them as complete, do not skip them, they're important. But I'm going to talk about some of these commands that are in the system information section. So to start off, who am I, for example, just tells you what user the command was run in the context of. So if I'm logged in as a user and I open up bash and I type in who am I, it'll give me my username. If I had managed to escalate my privileges and get a root shell, for example, when I typed who am I would get root. It just tells you whichever user ran the command, that's the username you get back. ID is very similar. ID will give me the user ID of my user, which in this case is 1000, as well as the username here. It'll give me my primary group ID. You can have users be in groups on Linux. You can put them into groups so you can help manage permissions for multiple users. In this case, there's a group that's actually named my username, and it's my primary group with ID 1003. And then it also shows me all the groups I'm in, which is that same group and then also the sudo group. So I can run sudo. Hostname will tell me the name of the system. It'll tell me the name of the host, which in this case is Pwnbox base. Uname is used to get information about the system. So uname -v usually gives you the kernel version, though on Ubuntu, this gives you the release of Ubuntu, so be careful. The target system on this section is actually Ubuntu, and if you do -v, it'll give you the release of Ubuntu instead of the kernel version. Uname -r usually gives you the release, though on Ubuntu it gives you the kernel version, hint hint. As we can see here, it's 5.14.0-2 for Parrot. PWD gives you the current working directory. It tells you which directory your shell is currently in, so it's going to be the home directory. Ifconfig will give you networking information, so your IP addresses, for example. So in this case, we can see that my ton0 IP, which is my IP on the Hack the Box network, on the Hack the Box Academy network, is 10.10.15.91. So if I were working on a module and I needed to, say, pop a reverse shell, I would feed this IP in. This is my IP on the Hack the Box network. You can also use IP for this, so I could do IPA, and it gives me the exact same information. Now, all of these commands I just ran, we talked about how they are binaries. They're executables that exist in a binary folder, but how does the shell know to run them? How does it know where to find the binaries? Was it just hard-coded into the operating system that the binaries are always in those folders? But what about times when there's new folders that binaries can exist in? How does the shell know where to look? It does this because it has access to an environment variable, a variable that's accessible on the system called path. And path contains the directories where the shell can find binaries. So I can print out to the console system variables by doing echo, money sign, and then the name of the variable. So in this case, path. And we can see these are all the folders that it will look in. Whenever I type in a command, it's going to look in these folders and see if an executable exists in that directory. And if so, it's going to run it. So the ones that it has looking for is a .local.bin in my home folder. There's snap.bin, user/local/bin, user/bin/bin. There's a lot of them here that it's looking for to find these commands that I'm running. So for example, if I wanted to do something very bad and overwrite this path, the shell would not know where to find any of the commands and I wouldn't be able to run anything. So I can do that by doing export path equals nothing. And right away, the vpn bash.sh script, which is what puts the IP into this shell prompt here, my IP of Pwnbox, that's what puts it in there. It is breaking right away because it can't find any of the commands it needs. It can't find grep, it can't find cut, it can't find IP. None of the commands that it needs can be called anymore. If I try to do ls, it can't find where ls is. However, I could still manually specify where ls is. I could say, okay, I want you to run ls that's in this specific folder. This is called an absolute path. I'm specifying it absolutely. So instead of it having to go and try to find ls, I'm telling it where to find it. Now that works, but I can't just do who am I or cd. It won't work unless I specify the absolute path of the binary, of the executable, of the command. Now I can recover from this because the shell will still take the export command. It'll do that. And I copied the path from earlier. So I can do export path equals, and I'll paste that in, and I'll run that. And now my path has all of the locations of all the binaries again. So if I do ls, it works. Our little VPN script to insert the IP here is now working once again. everything is fixed. So that is your path, and that is how your shell knows to find all of the commands that you're running. And that is it for this video. We talked about a lot. We talked about the entire Linux structure in terms of the root directory and what's in it. We talked about some basic Linux commands and using the terminal. So go back to the module, read the introduction to shell, prompt description, and getting help sections. Go to the system information section, read it fully, scroll down to the bottom, and there's going to be a target system there. You're going to spawn a target system. There'll be some assessment questions for you to answer, and I want you guys to go ahead and go do those practical questions. Put what you learned here and in the module into practice. That's your homework. And until then, I'll see you in the next video. Goodbye, world.